Welcome back. So in the last class, we began our look at projectile motion, and we focused on problems where a ball or a cannon was fired horizontally, so to the right, I guess, and we tried to figure out how far it would travel. So to do that, we determined how long it took for the object to hit the ground, and then once we knew the time in the air, we multiplied that time in the air by the x component of the velocity, so velocity times time gives us distance. Notice this works because there's no acceleration in the x direction, so all of the acceleration is from gravity, and so it's in the y direction. So the strategy is to find the time that the ball is in the air. Now that we've done it a few times, we can see that the general form of this is that the delta y is equal to the initial velocity in the y direction times time plus 1/2 at squared. But in this case, v0 is 0, so that means that delta y is equal to 1/2 at squared, and then we can do some algebra and solve for t, and we find that the time is equal to the square root of 2 times y over the acceleration. So remember, this is a special case where the initial velocity is 0. So hopefully at this point you understand how to do the problem. So if you want to, you can just do this, but be careful. If you don't know why a formula works, then there's a good chance that you will just end up using it wrong a lot. But if you know why you're using, it's fine just to jump to this. The other reason I bring this up is that thinking about how the time changes as we change the height. So notice time is equal to the square root of 2y over acceleration. For dropped objects, acceleration is a constant, and 2 is a constant, but y, the height, we can change. So the height is inside of the square root, so that means that if we double the height, the change in time will be that it takes the square root of 2 times longer for the object to hit the ground. So the square root of 2 is about 1.41, so if you double the height, it will take 41% longer to hit the ground. This should make sense because as the object falls, it's going faster and faster. So the second half of its fall will take less time than the first half. So how high do we have to lift the ball to double the time? Well, we need the square root of y to double, so that means we need to increase the height by a factor of 4. So you take the square root of 4, and that gives you 2, so the time in the air is doubled. We can do a quick sanity check on this. So if we drop our ball from 5 meters, it's going to take 5 seconds to hit the ground, and if we drop from 4 times that, 20 meters, then it's going to take 2 seconds to hit the ground. So we quadrupled the height, and we doubled the time it took to hit the ground. Okay, so let's look at our question here. So we are asked about 2 balls that roll off of a table at the same height and the same speed, but they have a different mass. Well, in this case, the only thing that is different between the two is that the masses are different. So the acceleration doesn't depend on the mass, so the mass doesn't really matter for how far the object falls. What matters is the velocity and the height. So the distance depends linearly with velocity, so the ball is moving horizontally with constant velocity, so if the ball is rolling twice as fast, then it's going to go twice as far, assuming that the height is the same. The height is also the same, so we saw that time is proportional to the square root of 2 times the height over g, so the distance will increase with the square root of the height. But in this case, in this example, the height is the same, so same height and same velocity, so that means that the two are going to hit the ground at the same horizontal distance. So our next problem, one ball rolls off the table that is at 0.5 meters, and ball 2 rolls off the table that has a height of 1 meter. So ball 2 has a height that is twice the height of ball 1. They both have the same initial speed, so the only difference is the height. Well, first, the higher table, the ball 2 should travel further. So by how much? So remember, the time is proportional to the square root of 2y over g. So that means that the time in the air is proportional to the square root of the height. So if we double the height, we take the square root and find that the new time will be the square root of 2 longer. The velocity is the same, so the distance will be proportional to the height. So the distance will be proportional to the time. So that means that x2 here will be the square root of 2 times x1. Okay, so you have some questions to answer. So one asks, what happens if we change the velocity at the same height? Well, the time the balls are in the air will be exactly the same since they're falling the same height. However, the ball that's going faster will travel further. And so that means that the distance will be proportional to the velocity. So if you double the velocity, then you will double the distance. And so if you triple it, you will triple the distance. The other one changes the height, and it's pretty much the problem we just did, right? So it's going to be proportional to the square root of the change in height. All right, so good luck, and next we'll look at launching objects at an angle.